Let's go. I'll present to you a novel hybrid compartmental stochastical model to address the coronavirus spread, considering vaccination in hospitalized cases with bed requirements. I'm Dr. Alysson Diógenes. My research was performed also with Dr. Daniel Tedesco. The context is that the COVID-19 came from Wuhan to the world in the year 2020, and several mathematical models were used to predict the disease behavior. And also, these models were trying to predict the disease behavior to help to manage the stress in the healthcare system. Several mathematical models are basically divided in two types of models. The first one is compartmental, where we can quote the SIR is the most famous. They divide the patients in the population in susceptible, infected, and recovered sections. And they also have similar models like CIRD. They include dead people, and SIR, they include exposed compartment, and also combination of them. These models are sort of realistic because they use words and compartments that are familiar to us, as all of us knows what's a susceptible person, an infected person, a recovered person. But they use differential equations that tend to be hard to solve and very computer demanding their solution, and also they can or they may or may not be solved by common mathematics. Also, there are other mathematical models that are the stochastic models. They use curve fitting, and they can be realistic if you can adapt these curves to parameters that we can recognize. We are used in our research the simulated annealing approach, where you have the probability to accept or not accept an iteration that changes the curve you are trying to fit, and using original curve. Commonly the case is data, and these modifications are accepting using temperature scheduling that changes a long time. The Curitiba city, where we are in Brazil, has a population of almost 2 million people in 2021. It stays at South Brazil, and it's pointed here in state of Paraná. It's the 80th most populous city in Brazil, has a demographic density of almost 4,000 inhabitants per kilometer quadrant, and has several parks. I've noticed that everyone is sharing some photos of the city. It's very nice. Here are some of our parks. One very interesting, it's a memorial for Ukrainian immigration. Talking about the Curitiba COVID data, the Health System Secretariat usually posts COVID data daily. It's not every day, but most days they're posting. When they don't post, they will post in the next day for the accumulated data. They post active case, confirmed case, deaths, recoveries, ICU, and bed requirement data. And the peaks we can see in these curves here are the original strain from the coronavirus. It reached Curitiba by June from 2020. And also the Brazilian strain, the Gamma strain, that reached Curitiba by January to March mainly. And also we have a smaller peak here. It's about the Delta variant. So talking about our model, we named it Serviced. model, because we added susceptible, infected, recovered, vaccinated, critical for ICU beds, hospitalized for clinical beds, and dead. And all of these compartments are connected to each other according to this diagram here. And they have parameters that must be solved using all of these equations here. And they were discretized using discrete time difference equations. And now they are not solved by using conventional differential equation methods, but they are solving using a regular computer. And we used an approach by solving them using simulated annealing techniques that's very fast and that can really have nice results. The input data uses 7 typical days for keeping a moving average. Each constant is calculated by the simulated annealing method using data fitting, and it was reading a C++ code using input data very similar to these ones here, where every compartment has data that came from the Health System Secretariat. The results, there was made our first convergence test for a 100-day period with no vaccinated people and also not using the Curitiba data. The results are promising since the susceptible is falling as expected. The infected curve went up and then went down. The recovered increased. And we had 2 interesting peaks here from the clinical bed requirement and ICU bed requirement. There was just a simulation, a convergence test that has no connection to the real data. So the next step was to add vaccination. And then we made a test with 500 days, adding the vaccination. And it was very interesting because the susceptible falls in a different way than the previous curve. And now it's more straight than just a sigmoidal curve. That indicates that the model is working. So we added an example of Curitiba data fitting and predicting. The left side of this graph is for Curitiba data fitting, and then the right side predicting. The fitting was very good, and we can see the difference between the original data and the fitting data. But the prediction wasn't, it had unexpected behavior, since, especially in the hospitalized data, it was oscillating, and then after we started to predicting, it was very flat curve. It was expected to oscillate a few also. And also in the critical requirement, critical bed requirement, the data was oscillating, but the prediction was very straight falling, and that did not seem to be realizable. The discussion. The model is promising, and the parameters were adequately fitted using simulated annealing model that indicates that a hybrid stochastic and compartmental model could be developed. However, we used the susceptible number of people to fit the Curitiba adult population, and that became negative during the prediction. That was also an unexpected behavior, and we are dealing with that for future research. And also, when we predicted the data with vaccinated people here, and 300,000 people would end the outbreak, and that's also incoherent. That does not make sense. Both observations here are caused due to reinfections and also that recovered people are also vaccinated. That is real, but the model did not account on that. Those are topics for future research, and also this model could be able to model variant to new virus strains, and also we might need a new definition for the R0 for the propagation model. Conclusions. A novel hybrid compartmental model was developed. The method named serviced was tested, and the parameters were solved using a simulated annealing technique. The data for Curitiba City was fitted, and the results, preliminary results were promising. We had issues about the recovered and vaccinated people because the compartmental model should not address superposition of those populations. However, the model has potential to deal with COVID variants, and data input is a real issue. We should work on that, and maybe we'll have a new definition for the R0 in future. The authors thanked our institutions, Universidade Positivo, and also Faculdades da Indústria Sistema FIEP, and thank you. I'm available for questions and answers.
Thank you so much for your presentation.